So this is our first project, and in this project we will try to explain few concepts before we start dive in other two projects which are the main subject of our course. The first thing we need to discuss is to set up our scene, the scale of the scenes. It's important, and as I noticed, most of the tutorials out there, they are not actually describing this well. Some of the tutorials are actually based on a wrong idea about the scaling, and it's because the scaling in 3D Max is not simple. We need to understand where is it coming from, and we need to understand how to set it up properly. So the first thing to understand here is to see where the geometry is coming from. This geometry is coming from Maya, and it was animated in Maya. So we imported this geometry as a fixed file, means the geometry here is modeled and animated in a program which has units, scale units different than 3ds Max. Just to give you an idea, Maya is dealing with centimeters. And when we bring this geometry from Maya as imported geometry here, we need to understand that the setting in 3D Max is different. So we can access the units and the scaling units in 3D Max by going to Customize, Unit Setup. Here we have two sets of parameters. The first one is here, which is the display parameters. By default, it's going to generic units, which has no units actually, and we can create any geometry which has no units. So doesn't show any unit, but it has actually units. So if you will see here, the box has length, width, and height, but there's nothing here which indicates it's in centimeters or meters. But if we will go here and change this into meter, now we can see that everything is scaled with meters, and we will know that the height is 2 or 3 meters roughly. That's good to know, but that doesn't reflect the actual units here, the actual size of this object, because that is not independent from the system unit setup. And to understand this thing, simply we will say that this units is the actual units we are dealing with objects here in 3D Max in terms of scale, which is useful to know exactly the scale of the geometry as well as the texturing and real world units for mapping. So before we go there, which is sometimes we need to understand that some of these matters takes time to explain, and we don't need to spend time outside of our main subject. So the first thing to understand is that this is in inches. So when we import any object here into 3D Max, the kind of units here affect the total scale of this geometry. The thing is that if I will choose this geometry, which is the wheel, and I will go here and right mouse button, I will see that the local scale or the scale of this geometry is huge. Knowing that the actual scale of this geometry I did in Maya was almost 10 to 12 meters. So that reflects here also here, and that affects everything because now we have this in our scale and in our scene. To exactly know how to modify this or to change this, we can rescale our geometry. Of course, because this is rigged and it has bonds, you can't just rescale everything just by using scale tool. What we can do is that we can rescale the skeleton, and if we have a node which indicates the scale of this character, we can use that. But again, this is considered not the right way to do this thing. Actually, we need to take in consideration when we import everything from Maya to here to set up Max in centimeters, import everything from a system which considers centimeters as its units to another program which deals with the same units, or to change Maya into meters, make sure that everything is right there and import it here in Maya in Max with a meter setup for the units. Other solution is that if you are dealing with just objects, what you can do is that you can go here and reset this, and that will make sure that it doesn't matter what kind of unit it has here, you will have 100%, which is the right scale. So actually I need to have this in 100%, means that I'm reflecting the actual scale of this well. But again, let's see in our case what we can do about this. Another way to do this is always to rescale your geometry in the sub-object level. So as example, if this has a scaling with 300, now I have 300 units, and here it's 300. If I will need to change the scale here in my scene, but to keep this, all I need to do is to apply Xform. So let's just convert this into polygon, and let's rescale everything here by rescaling the sub-objects. Now if you see the total scale of this object return to its original scale, but if we will go here, we will find it's 300 again. So that means that you can rescale things in the sub-object level. Anyway, that's another solution to do these things, but for our scene we don't need to mess with the character. It's best to not do anything with the character here. We need to find a way to make sure that we are simulating in the right scale. So what I will do is that I will see how Phonics is dealing with this matter or this problem. So if we will go to liquid simulation and we'll try to draw something which is roughly the size of this whale, we will see that here in the modify rollout we can see that there are some numbers, and based on these numbers we will see that here we have the y, which is the length of this whale, and it says 5 meters. So what we can understand from this is that for Phonics FD, the length of this is the actual length of the whale. This is how Phonics FD is seeing the whale, and that's the most important thing for us now. And this spare us from even doing any modifications here on the model or the geometry and trying to retain the right scale. But if we want to change this, one way to do it, because now it's not 5 meters, actually it's like 10 meters to 12 meters. So what I can do is that I can go to units here, change this to meters because I want to see everything in meters, and this is just for display purposes as you can see here. But I can go here and change this into centimeters as example, try to see again. As you can see, this is 2.5 meters almost, or roughly. I can go again here and I can change this as example to 5. It's not advised to change this thing, but it actually works. And if you just click OK, you will find that this is roughly 11 meters, which is the actual size of my whale. So now all I need to know is that Phonics FD is dealing with my whale the right way, and this whale is actually 11 meters, between 10 and 12 meters. That's all I need to know. This is extremely important, and this set up the way we deal with our scene. So if you create any object here, or if you import any object from outside, all you need to know, all you need to deal with is this number in the container. So if I will bring the container here again, put it here, let's display wireframe, and let's increase this number roughly here. If I want to know the length of my object here and how Phonics FD is seeing this object, all the changes here you will do, everything you may change reflects the actual size here. So this is the actual size. This box for our simulation in real world scale it's 34 meters. This is all we need to deal with and to understand. So I can delete my objects here, and I know exactly now that I'm dealing with the right scaling. Of course, again, sometimes you will see in some tutorials that this is 20. Sometimes you will see that it's in meter, and in meter it doesn't matter actually if your object scale is right, and this object scale is right because you know, it was made in Maya, and it was made roughly with 10 to 12 meters. So this is the first thing. The second thing is that the position of your object is extremely important also. So my object here is almost in the middle of the grid, as you can see here. So if I create any object like a box, try to put it in 0, 0, 0, it will be here. So let's do it. Go here and change it. It will be in the middle here. Means that it's in a good place to start the simulation and to do whatever we need to do. And what I mean about that, if this object is very far from the center, like here, and this is another mistake which I see a lot of people doing, Max is treating this object differently. There is a big problem when having the objects very far away from the center. And this increase when we do some simulations or another kind of camera animation even, and the camera starts shaking here, other problems will arise here, that based on the nature of floating point calculations and how digital world is treating the units. So when we have something like that, a scenario like that, and our scene is big enough and all our objects are far away from the center, it's advised to try to bring everything here to make the area of simulation in the center, to start doing whatever we need to do. So to understand this also, if you bring this object here, you need to understand that 3D Max is looking at it differently and the numbers here are changing. So if we go to unit setup, if we'll go to system unit setup, we have here some numbers, and this is the origin. If I will reset this just by the right mouse button, it shows me the resulting accuracy, which is good here. But the idea is that if you move your object far away from the center, the accuracy gonna be totally different. This is the relationship between the distance from the origin and how much problems you will have the accuracy. So again, right mouse button here and you return it to the 0. So you don't need to change anything here. Make sure this parameter will make sure that if you open a new scene which has its units, that it will be respected in the new scene. So 3D Max will pop up this mismatch message, will ask you to make sure that units in the open scene is the one which is considered, not the units in the previous scene. So all you need to do is to keep everything as it is here and start working. Make sure your object is as close as possible to the center, to the origin, as we have here. It's not far away from the origin. Now we can start working on creating our container and bringing everything to work. Unlike other courses and tutorials, we will not just go and create a fluid system here and start simulating everything and come up with some numbers which we don't really know how these numbers work with us. We will try to explain more about how VFXTREME is working and the engine behind everything. So to understand this, we need to go and to VFXTREME here and create liquid simulation container. Let's build it here and let's roughly make it contain the whale. And to understand the animation here, we can just run the animation and see that the whale is surfing up, then moving ahead before it sinks again. To see this, we can always create a reference plan which can show us how the movement is happening, and it can define also the level of water, which we will do in a later stage. This is our camera, and this is how the wheel is appearing. As you can see, it's very close to that camera. Then we can just see how is everything happening after that. So as you can see, the container is here, and if we will do the calculations, we need to make sure the container is including all the kind of particles or liquids in our scene. That means we have two options. First, to expand this container by selecting the container and going here. We have some settings here in the grid, and we can just make it longer. As example, move it ahead here, and that way we always have our wheel inside the container. Of course, we will try to make it roughly as small as possible, because as big as the container is, as big as or as consuming is the calculations will be. So again, let's see here, that's suitable and that works well, but we need to make it smaller, because if you go here, you will see these small cubes, and these cubes, what we call voxels. I'm sure everyone knows about it or heard about it before, but if you didn't hear about it, this is the units, the smallest unit which the simulator is taking into consideration when calculating the particles movements. So again, PhonicsFD is dealing or using a method which is a flip method or flip solver to calculate and run its simulation. And the flip solver stands for fluid implicit particles. What that means is that the old way of calculating particles was merely depending on the particles' positions and velocities. But in this method, we also taking in consideration other factors like the pressure. We take in consideration area of calculations, which defines the field where the particles can be, and the field will transfer some information between its cells, which is this kind of cells, which we call voxel also, because it's pixel but it's in 3 dimensions. Again, what we can have here is information, and every particle will be generated here will hold another kind of information, such as its velocity. Based on the particle position, it will take more information from the grid, and this information will define its next move and condition, like next velocity, position, pressure, and other information. This is how everything is happening inside PhonicsFD. All we need to know is that defining the steps here, how small is this cube, defines the accuracy of our calculations. So as small as these steps, as good as our calculations, but in the same time, as small as these steps, as expensive it will be for the program to run this kind of calculations. And we need to minimize this to speed up everything and to be able to afford doing heavy calculations and heavy simulation, beautiful simulation, and something which we can render and feels right and real, but with minimum kind of resources like your home computer. So to do that, it's advised to make this smaller. But when you do this smaller, you need to make sure that it's moving with our character. PhonicsFD is providing this way of making sure that although this is small, but we can animate this container, and it takes in consideration that the water inside it is in open surface. Means that it doesn't matter how this moves, the water inside it take in consideration that this is open and this is open, all the borders are open, and the water inside it is like a part of extended water surface. This is extremely useful, and it's controlled by some of the parameters here like motion interior. But to come to that, we need to explain few concepts here, because we will take in consideration that you don't know much about phonics FT. But we will move fast to work on our project, and it will not take much of time for us.